Okay, good morning. This is we on section 15.1, which is basically double integrals over rectangle, and so we know the idea here is that you want to find, for example, the volume of this object. This object is bounded above by a surface, which is represented by z equals f of xy, and below by the rectangle, which is it's exactly right below the surface, such that the f of xy will take any point on the rectangle, and then we'll map it to the surface. So this surface is right below, this rectangle is right below the surface. And if you connect all the corners, you're going to have an object. And the idea here is, what is the volume of this object? So we already went through the theory. So here, what I'm going to do is basically, so the volume of that object is represented by a double integral over r. R here stands for the rectangle, which is the domain of the function f of xy. So you're going to double integrate the function f of xy over the rectangle. Now the expansion is that when you have your rectangle, you're going to have the boundaries. So for example, here it shows you the boundary of the rectangle. The rectangle is basically bounded by in terms of x. Sometimes, so basically the first interval, the closed interval, gives you the boundaries for x. So x is bounded by a and b, and here y is bounded by c and d. So we basically say AB cross CD. It gives you the rectangle. So one way to express this double integral where you don't have limits of integration is to actually do limit of integration. For example, we know the limits for y are between c and d. So if we decide to integrate with respect to y first, then the inner integral is going to be from c to d. So this basically given respect to the y values. And then with respect to dx, so you have ab as part of the limits of integration of the last integral. So this is called the inner integral. That's just called the outer integral. So when then you can also change the you can reverse the order of integration. If you decide you choose to integrate with respect to x first, then you will put limits of x first, which is from a to b, and then integrate with respect to y second, then you have c to d. So for example, let's do an example where we have some kind of challenge. For example, here you're asked to evaluate the double integral of over r of x minus 3y squared. So this is the function of two variables, f of xy, and you turn to double integrate over r, and r is given as such. So r is the set of all xy such that x is between 0 and 2, and then y is between 1 and 2. So you want to double integrate the function f of xy. So you have to decide whether you want to integrate with respect to x first or with respect to y first. Okay. So like here I choose to integrate with respect to y first. So this is for y is first. Then I'll put the limit of integration in terms of y here. You can see the limit of integration in terms of y are from 1 to 2. Then second, I will integrate with respect to x. So which it says here, this is last, so that's last. Okay, so you integrate with respect to x, then you have the boundaries for x also, 0 to 2. Now when you do double integrate, you always do the inner integral first. So since we're going to integrate with respect to y, then everything that has x on it will be considered as a constant. Okay. So like here, because we're integrating with respect to y, then this x is going to be treated as a constant. So you're going to have x times y when you integrate x. And then when you integrate the 3y squared, you get the 3y cubed over 3. And make sure you write like y equals 2, y equals 1 here. Just to make sure, to remind yourself that you actually are going to plug in the y values. Okay. So after you integrate, you simplify, then you can plug in 2 for y. Okay. So you put 2 for y, and then 1 for y. So I did like I did this, and then I did that. So I used this function. I evaluated at 2 and 1. So plug in 2 for y, you get 2 minus 1 and then times x. Then minus, this minus here, and then I plug in 2 for y and then 1 for y again. So 2 cubed minus 1 cubed. So you get, so 2 minus 1 is 1, 1 times x is x, 8 minus 1 is 7. So you get x minus 7 that you're going to integrate with respect to x. So that's just one integral we know how to do. Find the antiderivative and then plug in 0 and 2 to get negative 12. So that's an example, one example for to do how to integrate a function of one variable. Thank you.